Well, welcome back to RDWorks Learning Lab for a different disaster recovery session. We're back at the machine now after a few days. We're just going to try and repair the machine after my little bonfire that I had in here. I've managed to get a new timing belt. It's supposed to be a round form belt, but this appears to have flat tops on it. But it is the correct pitch at 3mm, but it's come in as an HTD timing belt. It is the correct width at 15mm. And as a closed belt, I've ordered it at 1569mm long, because 1569mm long is over the length that I require to span the machine, and then I'm going to have a piece missing here where I'm going to join it. I don't know whether this is a continuous timing belt or not. If it's a continuous timing belt, then I've bought the wrong one because it's too long. This sort of belt, because it's got continuous strands all the way round it, it will only have the correct tension provided you don't break it. Therefore, if you break it, the chances are that you're not going to get the same amount of tension in it, because you're going to be pulling the strands, you're breaking the strands and pulling them. So I'm a little bit dubious as to what we're going to find behind here. But before we pull the head apart and take the belt off, I think first of all we'll have a go at trying to clean the slides, because I don't want to move the head over this slightly dodgy area here. So this slide is survived virtually damage free. There was just a little bit of soot on there and that was all. But this one, I suspect partially because of the heat, when I sprayed the fire extinguisher on it, it probably has caused this surface to rust up a bit because it was dry with the heat, and then I sprayed some watery stuff on it. Oh, by the way, I'd just like to thank John for being inspired by my recent video. I don't exactly feel like a saint at the moment. I feel more like an idiot. So I'm trying to work out what the best thing to do to take that surface off there. Fortunately, it's not on the bearing surface except just along that top edge there. I can feel that that is a little bit, yeah, okay, it's not going to be too bad to get that off. In fact, what I might try and do, here I've got a very light abrasive pad, and what I will do, I will first of all try and take that, as much of that off as I can. I think probably with a solvent. I'll probably do it with something like acetone. I was taking some of the staining off the surface, but I don't think it's actually moving much. So I think some of the debris under here will be where the belt has caught fire and fumed up underneath here. It's definitely black under there. And I can feel it's rough. I think we've only got one thing to do now, and that's to gently tease away anything that's on the surface. Now bear in mind, this is a hardened strip, so you know I'm really not going into the surface very much at all. Feels a lot better. Shell grease here, which we will use to just grease the slide up to start with. That will hopefully pick up any debris that's on the slide there. So if there's any chance of dust or debris on there, hopefully it's picked up and it will come off with the grease. Just apply film to the surface to stop it going rusty again. And there we go. Now I'm not going to move that at the moment because this belt is very fragile and I don't want it to go round the back. What I do want to do is to undo the head here. I just have to take the head off completely, I think, and have a look, see how the belt is fixed on. Right, we've now taken the head off, and thinking about it logically, this belt cannot be continuous because it passes through the centre of this cross beam here. So it must be split behind here. So this is a plate that I made fix my head on. And let's have a look what we've got behind here. So behind this bearing, here we've got the fixing plate for the belt. And there isn't a great deal fixing that belt on there. I'm not even sure that these are toothed plates, which I think they should be. I think they look like just ordinary flat clamp plates. Another bit of tacky engineering. Before I do anything, just at the end here, look, we've got this strange bracket, which is a jacking bracket, so that I can tension up the belt itself. So before we go any further, what I'm going to have to do is to let the tension off of the belt. I mean, I don't need to, because I can undo these and the belt will just fall apart, but I've got to slacken the tension off there so that when I put these back on, I've got some way to tighten the thing back up again. Now, the screwdriver slots in the end there are obviously impossible to get to, but if we look along the machine here, we'll find that there's a hole in here. So I'm undoing the control enclosure and I can get through from the inside there, and I do believe that when I pull this forward, I would expect those holes to line up with, and they do. There it is, it's an 8mm. Well, I wouldn't say they're locked up. Not exactly a great deal of locking force on there. So we need to undo those. Pull it along to get to the next one. And undo that one as well. That slackened the belt right off. And now we should be able to remove these screws. Well, as I suspected, there's no teeth in that. It's just literally a plain clamp plate. So, yeah, not overly impressed. Now, you can buy proper clamp plates for this belt, and I didn't. And I think I'm going to be a little bit careful about this because I can save myself a lot of effort. If I cut this belt first, it says on here, do not crimp. I think this belt was well and truly crimped on the end, but we don't have a choice because that's the way that it works. So I suppose in principle, once I clip this belt, I've removed its ability to transmit the rated horsepower. But of course, I suppose we're not actually using this for very, very high horsepower loads. Now those look like 4mm screws. So what I'm going to do is I'm just going to go to my drill and I'm going to drill a 4mm hole in there. Right, now what I'm going to do is I'm going to put this new belt on the outside of the old belt, and I'm going to wire them together. Now I could stick them together with masking tape, but I think wire is probably a little bit more durable. I've tried to make it flexible wire so that if it comes across an obstruction in there, it can drag past it. And what I'm now going to do is hopefully feed the belt through this here without any trouble. So it's going to be a little bit troublesome getting round there, but once we're past there, hopefully it should feed through. And the only next trouble I'm going to get is when I get to the other end there. But hopefully, and here we are. So that was pretty straightforward. New belt in place, not installed, but at least in place. Now some of you guys will have the right equipment and some of you guys will not have the right equipment to do this job. I'm debating whether or not I should actually manufacture a proper clamp plate out of a piece of 3mm stainless steel. I've got a little mill over there that I can use, and I've probably got pieces of material around that I can use. So I'll spend a few minutes and see whether or not I can make a proper clamp plate. The old belt, which is underneath here, has definitely got a round profile on its tooth. You can see that. And yet the new one a flat profile on its tooth. So the belts are not exactly the same. They're the correct pitch, but not exactly the same. I made a clamp with a little tooth on the end. So at least there'll be one tooth to clamp it. If you buy these normally, they have a whole set of teeth, like they're the reverse of this. So you get a lot of teeth clamped. So instead of it being just 8mm wide clamp, as the previous one was, this one is full 15mm wide, so it gets much better clamping load on it. Now the problem is trying to get it into the right place. Put it into a tooth and clamp it there. And I'm going to use a toolmaker's clamp because I can get closer. If I use a G-clamp, I never do it. So I've got a 3mm drill which will go through the middle of the M4 hole. Without drilling a hole in my hand. We'll open it up to 4.1. So the way that it's worked out is the tooth is just about on the edge, just hanging on the edge there. So that means it's all clamped, and then there's a little teeny weeny kink in here as well, just before the tooth clamps it. So when I tighten it up, and I won't tighten it up until I've fixed it onto here because we need to slide it up and down to get it central. Right there. And then we'll cut it off to where I can see the other belt needs to go, which is about here, in line with, roughly in line with this edge. So we get one shot at this. If we cut the belt too short, we're in trouble. There we go. And then we should be able to do the same trick with this one. So while we've got this apart, I suppose you could actually see how I manufactured my little adjustable head bracket. I took the existing bracket and cut the side off, and then I replaced it with this plate, which is a piece of 16 gauge stainless steel, and it's got a couple of hank bushes on the back so that I can mount the bracket on it and make it adjustable. These 4 screws here are the screws that obviously go through here as well. Now before I put the screws back in, I've got to put my bracket on. So let's put some tension. Now that's interesting. You can hear that wow, 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 wow. Right, now we're looking right down at this drive wheel which the belt runs round. So this is the stepper motor here, and it's driven directly off of this very small pulley. I'll just zoom in. If you watch what's happening to the bottom of the pulley here, when I run the head backwards and forwards, don't be confused by this top ring here, because that may be eccentric. What you're looking at is the teeth themselves. The whole pulley is slightly eccentric, so when I do this, if you listen carefully, I can feel the tension going on and off of this head. So look, if I put a pencil mark on there, and a pencil mark on here, See, one revolution is about 40 millimeters. So that's not the cause of waviness, because otherwise it'd have a 40 mil pitch waviness, and it's not 40 mil pitch. But it does mean to say that any dimensions that we put on here are not going to be perfectly linear. There's going to be some sort of cyclic waviness in the variation of the dimensions. Oh well, not a big problem, just a very small issue. Well, the main thing is, I'm just going to hook that up somewhere. And I'm going to turn the machine on and find out whether or not we have any additional problems other than the belt. It doesn't look as though we've damaged anything. So we should turn the machine on and see whether it sets to 0. Well, okay, so that's very good news, because it does mean to say that I've got my machine back now. All I've got to do is set it up. As I've said before, I think I'm a very lucky boy, and I hope you might be able to learn from this. This was the test piece that I was doing, and what I then did was to physically cut this piece out of the solid large piece of wood that I had in the machine here. Now when we look at the back of this, we can clearly see there's lots of flame and smoke in this area here, and in fact when we get to here it disappears, because what we've got is just a huge amount of burning on the edge, scarring and charring in fact on this back edge. You know, I can still take char off that back edge even though it's been washed. So undoubtedly that was the cause of the problem. So if ever you cut wood, make sure you take it out of the machine. Walk away from your machine knowing that there's no risk of fire. Something I advised about early on, but I'm sorry, I didn't listen to myself. Yes, when I bought the machine I thought this LED pointer was probably an essential thing to have. But now that I've used it, as you've probably noticed for the past, I think everything except probably the first month, I've had it pushed out of the way because it's nothing but a blinding nuisance, to be honest. The next thing that we've got to do is line the head back up again. So we're just going to use the masking tape trick. And I suppose before I go any further I ought to just take a look at that mirror there and make sure that it's not dirty. Because they're molybdenum mirrors, I don't have to be too careful about it. I can use some acetone and check whether or not I've smoked that mirror at all. What do you think? I think part of what I'm picking up in there is smoke fumes or smoke debris from inside the actual tube itself. Now this one was nowhere near the smoke, so I don't think this one will be damaged. But let's be doubly sure, and we'll just give that a clean as well. No, that's okay. Right, we put the head right close there so we can see. Just make sure my power is set to minimum. See, I've got my speed set to 5 millimeters a second. That was what I was cutting. That was what I was cutting at, very, very slowly. I should have been doing probably 12 or 15 millimeters a second. The problem is when you cut wood, the smoke goes right through the other side, and because there's so much excess power coming through the cut, it sets fire to the smoke underneath the cut. So that's where I went wrong. I should have gone a lot faster so that I didn't have any residual power underneath the cut. Let's do a quick pulse test. Well, that's not too bad. So sadly I haven't got my red dot pointer set up this time, so I've got to do it the hard way, and that's to sort of guess and pulse and guess and pulse. And as I twist this one across, it's going to take it up as well, so I've got to I know what that is. That was probably the acetone sitting inside there. So we've got the right height, but we've overcompensated on the distance. And now we'll see what we've got here. I would say that that's probably spot on, but what we'll do, we'll just do this end, which is that, put a little teeny weeny white mark on there, and there we go. As I've had the head off, I ought to check that it's upright, which it's within a very small amount it is, but I might just loosen one of those screws off at the bottom or the top and just gently set it upright. Now, as I didn't take the bracket off of here, technically I would expect it to be upright in this direction, and it is. And then finally we need to do our anal thermometer check. Okay, bend over please. As you can see, they're not perfect. The one in the middle is a little bit low, but the others are not bad. I'm certainly not going to worry about it at the moment. The reason I'm not going to be too concerned is because very shortly we're going to have a session where I reinstall the copper mirrors, and then I'm going to have to be a little bit more careful about setting everything up. So I'm certainly happy enough with that at this moment in time. Well, I hope this this bad experience for me has also been a good lesson for you. You know, I can tell you not to put your hand in the fire, but of course until you burn your own fingers you won't realise that the fire is hot. It's human nature. Good luck with your own fire. Bye.